Assalamu alaikum wa rahmatullahi wa barakatuhu. So in the previous lecture we were looking at the functions of a random variable, in which we have seen the derived random variables and how we can find the PMF of the derived random variable. So let's start with an example to continue with the same topic. So let's copy it from the book. So this is example quiz 3.6, in which says that we have to monitor 3 customers purchasing smartphones at the Phone Smart store and observe whether each buys an apricot phone for $450 or a banana phone for $300. So we have to look for 3 customers who are purchasing the phone, either apricot or banana. The random variable n is the number of customers purchasing an apricot phone. So their PMF of this n, for that's the purchasing of apricot phone, is already given. So we have this 0.4. If no customer is buying apricot phone, and with the probability of 2, that either 1, 2 or 3, all of the customers or 3 of the customers buy the apricot phone. Now it says that the $m is the amount of money paid by 3 customers. So we have $m that are paying, means if one person has bought this apricot phone, so they will pay $450, and the rest of the 2 they bought this banana phone, which is 300, so it would be 450 plus 600, 1050, and so on. If all of the 3 buy the banana phone, so n is equal to 0. So in this way they will earn $900. Similarly, if all of them they buy the apricot phone, so it will be $1,350. So on. That's quite simple, straightforward. So m is the dollars amount of the money paid by the 3 customers. So what's required in the first place? It says that express m as a function of n. So we have to generate a function for it, which is a function m as a function of n. So let's start here. So again I will say, so we will go step by step and see what's the price we can obtain for each of them. Means say m is equal to, so if none of the person buys this apricot phone, so it means that 450 into 0 and plus because we are looking only 3 people, so 3 people will buy this banana phone, so they will get $900. Similarly, if we say that one person buys apricot and the rest of the 2 they bought the banana phone, so we will get 1050. So similarly, if we say 2 customers buy this and 1 customer buys this one, so it will be $1,200. Similarly, 450 into 3 plus 300 into 0, so that would be 1,350. So if we look closely to these steps of how we can generalize this in the form of n, so because n is the range of n is 0, 1, 2, 3. So we can say that m is equal to, if we look here at this one, so we can see that this is increasing. So this is 0, 1, 2, 3, straightforward. So we can say that 450 into n plus. Now if we see this one, it's actually reducing, but they are reducing in a way that if it is 0, then it is 3. If it is 1, it is 2. If it is 2, it is 1. So it means that if it is 3, it is 0. So it means that it should be 3 minus n, because if n is 0, so it would be 3. If n is 1, it will be 2. If n is 2, it would be 1. And if n is 3, it would be 0. So this is 450 n plus you can say that 900 plus minus 300n, so that would be 150n plus 900. So this is the function, the required function of m, the amount dollar paid by the customers in terms of n, that's the number of customers buying the apricot phone. Now the second part says that we have to find the PMF. We need to find the PMF of m, which is Pm of m. Now again we will go the same way. We know the range of n, so I will write it here again so that we can clearly visualize it. 0 1 2 3 4, sorry, not 4, just up to 3. So s of m will be straightforward, just putting 0 here, so it will be 900. If you put 1, so it will be 1050, and if you put 2 here, so it will be 1200, and if you put 3 here, so it will be 450 plus 9, 1350. So this is the range of this. Now it has all the distinct and unique values for 0 and 1 and 2 and 3 and so on. So probability model will be same that we have defined in the previous lecture. So PMF of m would be simply then, because probability would be the same, 0.4 for m is equal to 0, that was 900 here now, and it is 0.2 for m is equal to rest of the values, 1050, 1200 and 1350, and obviously to complete it we need to write 0 otherwise. Now it says that find the mean or the expected value of m. So expected value, obviously we know that it is defined as m summation on the m that belongs to range of m times PMF of m. Now here m is say this small m is 900 plus into 0.4 plus this one has the probability same, 0.2, and these values will be added, 1050 plus 1200 plus 1350. So this comes out to be 1080. So this is the average value of the dollars or the amount they are earning for the 3 customers they are selling the phone to them. Now next we move to a little bit further. Next topic is the expected value of a derived random variable. So expected value of the derived random variable, the one method we have seen here in this, even in this example, that m is a derived random variable from n, and to find the expected value of m we have found we have completely figured out the PMF of this random variable m, and then we have used that relation to find out this expected value of m. So here we can define a little bit differently. So let's first define this. If y is equal to g of x, expected value of y can be calculated evaluated from PMF of x and function of random variable x without deriving PMF of y, which is the derived random variable. So that is quite simple. So it is defined in the form of a theorem here. So let's write this theorem 3.10. so it says that given a random variable x with PMF Px of x and the derived random variable y is equal to g of x, the expected value of y is obtained as expected value of y, which we call it as the say mu of y, which is summation x belongs to range of x, g of x, px of x. Now if you look closely, this is quite the same relation that we have used to find out the expected value of a random variable, which is x belongs to s of x, x p x of x. So if you compare with this relation, if we can see that the only difference here is instead of just x, we have now this function of x. So that is a basic definition of the expected value is going to be the same, only if we can use this function directly to find out this expected value of a derived random variable, expected value of y. So let's have this example. It is example 3.29, and it says that in some previous example we have figured out this PMF, which was 1 by 4 for x equal to 1, 2, 3, 4 and 0 otherwise, and we were given the function of random variable x as 105 x minus 5 x square for x is between 5 and 1, and 500 for x is less than 10 or greater than equal to 6. So this was the example that we have seen previously. So now it says that we need to find the expected value of y, we need to figure out. But instead of finding the PMF of y, we will use this theorem that we have seen now, directly find out the expected value of y. So expected value of y is then summation x equal to say 1 to 4, because px of x is defined only for 1 to 4. So that is g of x p x of x. So obviously so it would be g of 1 p x of 1 plus g of 2 p x of 2 plus g of 3 p x of 3 plus g of 4 p x of 4. So just now it's a matter of putting the values here. g1, it is defined as 105 into 1, so that would be just putting their value 105 into 1 minus 5x square, 1 square into px of x is 1 by 4. Similarly, it would be 105 into 2 minus 5 into 2 square into 1 by 4, and similarly plus 105 into 3 minus 5 into 3 square 1 by 4 plus 105 into 4 minus 5 4 square into 1 by 4. So if we just calculate these values, they come out to be 1 by 4 is common, so it would be 100 plus 190 plus 270 plus 340, which comes out to be 225 cents. Now we can see that it's exactly the same result that we have found in the previous example when we solved it by first finding the PMF of y and then applying this basic relation that we have seen here. Now we have used this relation directly. We did not find any PMF of the y, which is the derived random variable. So sometimes if it is not required to find the PMF of y, so it is quite easy to directly use this theorem to find out the expected value of a derived random variable. So there are let's move further at there are some important properties of the expected value. So the first of we can say that some important properties of expected value. So the first thing is that property 1. So it says that this first property has to do with the difference between a random variable and its expected value. So it simply means that suppose if the class average in a test is say approximately 70, and one of the student got the score say 65. So the student can think that the score is just a 5 points below the average. So we can say that y which is g of x, or we can say x minus mu x. So that's the points above or below the average, points above average. But here what we want to conclude here is that the expected value of this terminology x minus mu x will always be 0, regardless of the probability model of x. So whatever is the probability model of x, it does not make any difference. So if we find the expected value of the x minus its expected value, or its the mean, so that would always give me the 0. So this is the important property that we have seen. Now the second property of expected value, second property of expected value. So second property says that another property, the second property of the expected value, the expected value of a function of a random variable applies to linear transformation. So it simply means that if we have the function like this, ax plus b, and if we want to find out the expected value of this function, so this is a linear transformation, will be saying that we can find out this expected value of x plus b. Always remember that the constant, the expected value of a constant is itself. But there is another thing. Although we have called it as a linear function, but this function itself is strictly called as the affine functions. Means simply if we have this y-intercept type of things, so it will never cross the origin, so that's why it's not a linear function. So we can say that this is strictly speaking, these are called the affine functions. These are called the affine functions. So this is another property, we call it as the a scale change quantity, a scale change quantity, because we have seen that anything that's being multiplied here, that can be scaled out with the expected value of this random variable. So that will be the scaling factor for this expected value. So let's look at the example, and we will see how we can find out. So it is example 3.30. so we have PMF, we have find out somewhere from the previous example. So it is 1/4 for x equal to 0, 1/2 for x equal to 1, 1/4 for x equal to 2, 0 otherwise. And we have given the function v, which is the function of x, which is 4x plus 7. So expected value of v, so we need to find the expected value of v. So that expected value of v is simply the expected value of g of x, which is equal to the expected value of 4x plus 7, which is the same as we have seen here now. So it would be 4 expected value of x plus 7. Now the expected value of this function we have already figured out, which is given as expected value of x here is given as 1. So we can find out this one, 4 into 1 plus 7, so this is 11. So we can see that how easily we can find out by using this relation, or we can use the previous theorem to find out the expected value of v. I will just write it, I will not find it with that method. So that is previously what we have seen, summation of v that belongs to the range of v, g of x and p x of x. So if you figure out with this relation, you will find the same exact same answer for this problem. Now let's look at another example. So paste it. It is quiz 3.7. So quiz 3.7 says that the number of memory chips needed in a personal computer depends on how many application programs the owner wants to run simultaneously. The number of chips M and the number of application programs A are described by M is means 4 for one program, 4 chips for 2 programs, 6 chips for 3 programs, and 8 chips for 4 programs. And the PMF of A is given as 0.1 into 5 minus A, for A is equal to 1, 2, 3, 4, 0 otherwise. So what is expected? What is expected to find from here? It says that what is the expected number of programs or mu of A, or expected value of A. So the first answer is straightforward. We need to find out the expected value of A, which we can write it as A that belongs to the range of A times P A of A. So we can say that A is 1, so 1 dot, and it is 1.5 into 5 minus 1, so 5 minus 1 plus 2 into 1.5 0.1 0.1 into 5 minus 2 plus 3 into 0.1 into 5 minus 3 and plus 4 into 0.1 into 5 minus 4. So that comes out to be simply 2. So the next part says that express m, the number of memory chips, as function m is equal to g of a, the number of application programs a. So that's quite simple. B part, m is equal to, we need to find how many number of chips are required for any application that is running. So it means that for one program we need 4 chips, 2 programs we need 4 chips, for 3 programs we need 6 chips, for 4 programs we need 8 chips. So that's quite simple here. So we can write it directly, means we need 4 chips, either 6 chips or 8 chips. So this is for if we have these programs 1 and 2, we need 4 chips, and for 3 programs we need 6 chips, and for 4 programs we need 8 chips. Now this is the function that we get. Now it says that find the expected value of m, which is the same as the expected value of g of a. Now it says that does expected value of m is equal to this g of expected value of a. So we have to figure out these things. Now first we find this expected value of m. So expected value of m, because of using the theorem we are not finding the PMF of m, so it would be simply a is equal to 1 to 4 g of a into p a of a. So it would be simply 0.4 because we have done these calculations above. So plus 4 into 0.3 plus 6 into 0.2 plus 8 into 0.1. So this comes out to be 4.8. Now we know that expected value of a is 2. So g of EA, which is g of 2. So g of 2 means, for g of 2 is exactly what we had here. For g of 2 is 4. For g of 2 is 4. So we can see that this is not equal to expected value of m. So this is not equal to expected value of m. So sometimes it happens that the expected value of this thing and expected value of m, or which is a function of expected value of a random variable, they comes out to be the same, but not always. So we will stop here and continue inshallah in our next lecture. Stay blessed. Assalamu alaikum wa rahmatullahi wa barakatuh.